Section 9.1, we're introduced to the trig ratios in a right triangle. The trig ratios we're going to look at are sine, cosine, and tangent. You probably see these buttons on your calculator. This is actually a shorthand or an abbreviation for the word. This is sine, S-I-N-E, cosine, and tangent. So that's why we don't say sin or cos, because the words are actually sine and cosine. So when you see those abbreviations, you still say sine and cosine. There's an applet here you can go to follow along and learn how to label the sides of a triangle. I'm going to explain that here. For angle A, which is down in this right corner, I'm going to put an arc in that corner. They have already drawn this symbol here. That symbol is the Greek letter theta, and it is often used to denote angles in geometry or trigonometry. We're just asking you to think about which sides of the triangle are the opposite, adjacent, and hypotenuse to this particular angle. So the side opposite from angle A would be over here. This is the side that's opposite. And angle A has a capital A on it, so the side opposite is usually given lowercase letter a. The side that is adjacent or next to, adjacent meaning next to angle A, is side CA, and the hypotenuse, of course, is across from the right angle. So we knew that from before. The hypotenuse is opposite from angle C, so it'll be labeled with a lowercase c. And the adjacent side for A is going to be labeled with a lowercase b because it's across from angle B. Now let's focus on angle B up at the top. So here's angle B up at the top. The side that's opposite from angle B is down here. The side that's adjacent to angle B is on the left. And then the hypotenuse, of course, is that side across from the right angle. Now that we have that information, we're going to use the trig ratios we saw on the first page. We saw that the sine of an angle is the same as opposite over hypotenuse. Down here in number 3, the first question is asking me for the sine of angle A. So look at angle A in the drawing. I want the opposite side over the hypotenuse. So the opposite side from A is 5, and of course the hypotenuse is 13. So we want you to write the ratio 5 over 13. Now for cosine of an angle, that is the adjacent side over the hypotenuse. Okay, back to number 3. The cosine of A would be the adjacent side over the hypotenuse. Adjacent is next to, so that's going to be the 12 that's next to A over 13, which is the hypotenuse. And then the tangent is opposite over adjacent. So this one does not involve the hypotenuse. It has the opposite side over the adjacent side, and the opposite side was 5, the adjacent side was 12. So those are your 3 ratios for sine, cosine, and tangent. Now in number 4, we want you to look at a different angle in the triangle. For the sine of B, we want the opposite side, which is 12, over the hypotenuse, which is 13. And then the cosine of B would be 5 over 13. And then the tangent of B, tangent is opposite over adjacent. So 12 over 5 would be that ratio. Number 5, look at the different ratios we just got from number 3 and 4 and identify what the relationship is between sine and cosine and tangent of these different angles. So in that single right triangle, we had angle A and angle B were in the same triangle. Did you notice that the sine of A is the same as the cosine of B? And did you notice that the cosine of A is the same as the sine of B? And then tangent. The tangent of angle A is the flip of tangent of angle B. So we could write flip as 1 over tangent B. Number 6, we have a new triangle here. This time I don't have it labeled with angles A, B, and C. Instead, I'm using that symbol, that theta symbol. It's in the corner down here on the left. So focus on this angle here now. when you try to look for sine, cosine, and tangent. Pause the video and do these three real quick. The sine of theta is going to be opposite over hypotenuse, so that's 3 over 5. Cosine of theta is adjacent over hypotenuse, which is 4 over 5. And then tangent, remember, is opposite over adjacent, which is 3/4. There's a little something you can do to help you remember these ratios. We said that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So a lot of people think of this as SOH, CAH, TOA. So that's like a mnemonic device to help you remember the ratios for these trig functions. SOH, CAH, TOA. Please do number 7 on your own. So pause the video and turn the video back on to check your answers. The angle is in the bottom left corner, so we're looking at theta, and we want the sine of theta, which is 6 over 10, opposite over hypotenuse. We are supposed to reduce this. Did you reduce it down to 3/5? The cosine of theta is 8 over 10. That reduces to 4/5. The tangent is 6 over 8, which reduces to 3/4. Number 8. How do your answers for number 6 and 7 compare? Look back at the previous page. We also got 3/5, 4/5, and 3/4. Why are we getting the same answers? Look at the triangle for number 6. It's a 3, 4, 5 triangle. Look at the triangle for number 7. It's a 6, 8, 10 triangle. The 6, 8, 10 triangle is in the same family as the 3, 4, 5. So these triangles are similar. That's why they have the same trig values. Now I would like you to pause the video and do 9 through 11, and then turn the video back on to check your answers. Did you notice when you take the sine or the cosine of an angle, the top number in the fraction will always be smaller than the bottom number in the fraction? And that's because you're putting the number on top over the hypotenuse of the triangle. And we know that the hypotenuse is always the longest side of the triangle. So we're never going to see sine and cosine ever get bigger than 1. The tangent, however, can get bigger than 1. That occurred down here when we found tangent of y, and it occurred further up when we found the tangent of n. We know that tangent can become greater than 1.